Hi, I'm Bob Alsop with ShopSabre CNC. Around here they call me Router Bob. Behind me is a sheet of MDF Shaker Doors, and I'm going to show you how to make them. One of the most difficult machining operations that we do in wood CNC routing is making MDF doors. A lot of people don't realize that. And it's because we use multiple tools that are all cut at the same depth, and the cuts overlap each other. So if there's any discrepancy at all, it shows up. And not only that, you have to be consistent all over the table. So that's why it makes so much sense to use a machine tool grade router. For us, that's a machine with ball screws. The secret to the edge finishes and accuracies that we have on these ShopSabre machine tool grade CNC routers actually starts at the base itself. We build a base out of a one-piece, all welded steel frame. Everything is computer designed, and then what goes on to that complements that is our gantry structure. And the gantry, once again, is all welded steel. Everything's computer designed. That's really where you start with. Precision contour guide rails are actually the first part of machine motion, and what connects that to the machine frame is actually the quality of the machining that we do on the frames themselves. These frames are all machined on aerospace mills, so the tolerance of that machining is the tolerance of an aerospace mill. Now you couple that with precision ball screws. It doesn't make sense when you have that much accuracy not to use an accurate drive system, and that's why we use precision ball screws on all three axes. There's actually two parts to machine control. The first part is electromechanical. We use Mitsubishi closed loop digital servos, and we do that because they have a lot of power, and that lets us really get a lot of performance out of the machine, and they're rock solid in terms of reliability. But there's a part of machine control that's strictly people related, and that has to do with how your machine operator interfaces with the machine control itself. When we designed the ShopSabre machine controller, we wanted an easy to use interface that a good worker could master easily. We did not want to create an engineering position in your company. Let me show you how easy this is to operate. The buttons on the control screen are really logically organized into groups now. For instance, what you see down here is actually references the machine. This is the machine table. The red dot here is the current spindle position, and these are where the axes are set. So the origin's right there, and that's what determines where our part is located on the table. Now the buttons in this group up here are actually jogging. So we're jogging X positive, X minus, so you can see the spindle move. Same thing in Y, and of course in Z. And then you have fast, medium, and slow. Or if you want to jog incrementally, in this case I'm doing an inch at a time. Where I use this most often is when I'm doing a setup and I want to move the machine at 1,000th at a time. And then over here, when we're actually jogging, you'll see the coordinates update. It shows where the machine positions are. So that's real simple. Now, when you get into this area, these are things that you do more on a periodic basis. For instance, you home the machine when you first turn it on. You may set a XY0 at some point, or a Z0. Those are things that aren't done all the time, but they are done periodically. Tool touch off. Sometimes you want to turn the spindle on or off manually. There's a warm-up button here that you click on that and it turns the spindle on and allows the spindle to get up to operating temperature before you actually start using it. Now when you get over here, this is actually the program area. So let's take a look at running a program. I go File, Open, and there's the G-code program. And I'll click this View button and I see on the table what it's going to look like. And this is really nice because I can make sure that I visually validate this is the program that I want to run. And then all I have to do is hit the green button and it starts executing. And then if you watch on the machine control screen, you'll see it actually tracks the movement of the machine. And on this left-hand screen, it's actually processing the actual G-code. And then I can actually change, I can override spindle RPMs or I can override feed rates while the machine's running. That's real handy sometimes when you're testing a new material. So the screen was developed to make it really, really simple for the operator. Now let's go take a look at the spindle. This part of the machine has an interesting story. We call it Super Z technology. Let me explain what that really is. Well, we start out first with a HSD ATC spindle. ATC means it's a tool changer. And what we wanted to do is we wanted to really be able to get the maximum cutting capacity out of this. So the first thing we said, well, one of our challenges, if the part fits underneath there, I want to be able to machine it. That means you have to have more travel than you actually have underneath there. All right? And so part of the development of that came with what we call stiffeners, and there's a story behind that. First off, we said, well, if we want to increase edge finishes and accuracies, the stiffer you make that plate, the better that is. So we challenge engineering to come up with a solution. And they did about 10 different ideas, and one tested really, really well on our finite element analysis software, and that was this system. All right, so it tested out good, so we made the parts, we went out in the shop and we test ran it, and it came out just as good as the test said it would. Then we came back and we said, okay, how can we reduce mass? And that's what you see these cutouts without affecting performance. So that's the stiffener system. So that's the first part of this. The air balancing cylinder is another important part of Super Z technology. Let me explain to you why. First off, you have mass here, which is weight, that we raise and lower in Z. So we put an air balancer up here because that balances that, so that takes the weight off the ball nut. But there's another consequence to it. Because of that, we can accelerate and decelerate in Z much faster. That makes these machines cut faster in 3D. Now, when you put all that together, that's Super Z technology. For as long as I've been in the CNC industry, dust collection and panel processing have been a problem until now with the development of our new dust stock system. This machine has a phenolic vacuum table. We actually offer a number of different options on tables. The table itself is machined with the router spindle, and what that does is machines it perfectly flat and so accurately that you don't have to have gasket for these. This is also a vacuum table, and you can see the large vacuum ports on here. Those are actually hard tubed into a plenum that's actually an integral part of the frame itself, and you have valves so we can control vacuum to different zones. And then there's a large tube that runs to the back of the machine that connects the plenum to your vacuum system. Part locator pins are a great option on these machines because it makes it easier to load and unload them. And you know, something else that's neat about the way we design these, we put the extra travel on here, which makes these machines expandable. So if you need to add other options later, you can do that. Now let's go take a look at software. MDF Shaker Doors have become very popular for kitchens. The Shakers were actually a religious sect in the 18th century, and eventually they came over here during the 19th century and probably reached their peak right before the Civil War. They believed in simplicity, they made their own furniture, and everything they did reflected a certain view on life. And that style that they've created is very popular. Shaker furniture made during that period would be solid wood, and normally the doors would be frame and panel because of expansion and contraction. But they didn't like adornment. In fact, they felt like adornment was being prideful, so everything was clean and plain. So a typical door is 2 stiles, 2 rails, and a thin panel in the center. That's what we're trying to actually emulate when we make an MDF door. And Mozaik Software has that built in, and let's take a look at that. To start with, I made a little, a typical shaker door with VCarve Pro so I can kind of show you what's involved in processing. That's typically what one of the doors look like. The stiles and rails, a flat panel that was thinner, and straight edges there. So it's a very simple design. And normally they were made out of solid wood and would have been painted a number of different colors. Some could have been finished. But that's basically what we're trying to do. So here's how we actually do that. We start out first, and we'll reset our preview. First thing that happens is a large area gets pocketed out. That's what you see there, and that starts out with a bit that's a straight bit that's 1 1/4 inches. Then to get these corners square, we actually use 2 tools. The next step is to take a 1/2 inch bit, clean those out, and finally an 1/8 inch. And when we do all those 3 tool paths, we have something that looks fairly square. In fact, that corner would have a 1/16 radius, which is fine. So that's what a shaker door looks like. So what we're trying to do in Mosaic then is to create a set of MDF doors that have that look, and that's what's called a shaker door. Now let's take a look at Mosaic. Let's open up Mosaic and start out with the door libraries. So I've got Mosaic open. We'll go to Libraries, Doors. And these are all the standard doors that are already built into the system. I'm going to hit the tab that says routed because these will just be the routed doors. I'm going to select one that says shaker. That's what a shaker door looks like. And if you notice that if I simulate it, that's pretty much what it's going to look like, because there's the panel, it's pocketed in. So that's pretty nice. Now one of the things you can do is you're not locked into just this. If you want to customize this, it's really a concept we call sectioning. So I can put dividers in it. We'll take a look at those, so you can really make whatever you want. It's really that simple. Okay, but we're gonna go ahead and clean this out. Okay, now there's actually some tool paths that are involved. Okay, for one thing, when we select that panel and we say pocket, we tell it a depth. That's where the pocket depth comes from. But there's some other tool paths that are required, and those are actually in sets. So let's look at that. If we go to Settings, we go to Profiles, Outside Edge, Routed Doors. Okay, we're gonna in our case, we'll just cut the door edge with a straight bit, but here's actually what determines how we cut those. There's a shaker cleanup, and we'll go into greater detail later on what these tools do, but basically what I'm saying here is this is a tool set that I'm going to apply to that door to give me those square corners that we see right here that we saw on the video. That's basically what determines all that. And once again, we'll get into that later in the catalog. Now we're ready to start a job, but before we do that, let's check our material library and make sure that that's set correctly. The material that we use for MDF doors is actually what they call double refined, and the reason they do that is when you cut down in it, it's still nice and smooth. And then let's make sure that we get the thickness correct and our panel size correct. Okay, now we're ready to actually start a job, and I've created one called Shaker Doors 2018. And normally we just go down these tabs. Okay, this determines which, on a base cabinet, which door by default is going to be shown. And this would be a wall cabinet. And then sometimes you have things that are called decorative panels. A decorative panel could be the back of a cabinet, it could be an end cabinet. In our case, I want to make some wainscoting. And so for my decorative panel, I come down here, and once again, for a base decorative panel, that basically tells it which door template to use. Okay, now let's go on down here to room. Let's do a quick room. We'll throw a wall out here, and I'm going to make that wall about 100 inches. All right, so the first thing I'm going to do is create that. We'll go down here to products, and I'm lazy, so I'm just going to say auto build the wall. And that actually puts the cabinets on there automatically. And since I had shaker doors as a default, I don't really want the base cabinet, so we'll just get rid of those. And now let's take a look at this in 3D, and that's what we have. So there's our wall cabinets. We've got the shaker doors, and that looks really good. But what I wanted to do on this demonstration was also show you how to make wainscoting, because it's really nice and it's a great way to do it. All right, so we'll close this. Now what I'm going to do now is just take a simple cabinet and turn everything off. So I'm going to take this little cabinet here. We'll edit it. Okay, the first thing I want to do is I want to say, okay, this is the face of it, but I want that to actually be, let's say it's a panelized end, all right? And let's see, let's turn the parts off. We don't want to build anything. So that takes care of getting rid of the parts. And the other thing is let's make this the thickness of the door itself, so 0.75. And if we look at that in 3D, that looks good. Let's close out on that. Now let's look at this. There's the room in 3D. We'll fill it. Okay, we just need this bigger. So let's go back to this front view and let's grab this and watch what happens. See, they get wider, it automatically, but I want it this big. So when we looked in the door library, you saw where I said when it gets to a certain size, that's what that does. So that's all it took to make wainscoting. Let's look at that in 3D, and that's what it's going to look like. So it's really, really simple. So what I wanted to do on the machine, I actually wanted to cut that wainscoting and some of those doors. All right, so the process for that is real simple. Okay, we just move on down here. We'll go to cut list, and I'll go to optimize, and the 3/4 MDF is what we're optimizing. Think about optimizing as nesting. And that brings us up here. And let's optimize. And that's the sheet we're going to cut. But before we do that, let's look into how all the tools are set up and what the machine has to be set to in order to actually make these doors. Our friends over at Vortex Tool sent over this tool set. This is actually a special set just to make MDF doors. And so let me show you what each one does. If you remember in our little graphic simulation earlier, the first thing that happened was it got pocketed out in the middle, and that's the tool that was used for that. That's an insert tool, and it actually comes with a set of inserts. Okay, then the next thing we were trying to do is clean the corners out, and that was done next with this tool. That's a 1/2 inch compression bit. That's actually a mortising bit. And then finally, we use this little 1/8 inch bit to clean those corners out. Now there's another tool in the set, and it's actually a V-bit. And in some instances, you may want to add that. We typically don't when we're hand sanded, but if you were thermofoiling, you might add a little chamfer operation to it. And then of course the outside of the panels are typically whatever we use for cutting panels out. Now let's look at how the tools are actually set up in the software. You go to the library, you go to CNC tooling, and we'll expand this out a little bit, and you'll see tool properties, panel tool groups. Okay, let's select one of those. This is one that says shaker cleanup. Now the reason it's cleanup is because the main pocketing is done a different way. All this tool set does is clean the corner out, and this is what we saw in the simulation. So the first tool is a down shear tool, and that's a 1/2 inch, and the second tool is an 1/8 inch. So those are the two tools that are actually applied. And I set the depth at a 1/4 inch because that's how far back I wanted that panel. All right. Then those tools are actually used as with a tool set. So in the machine itself, this is where I have a little tool set called Vortex MDF Shaker. Okay, this is the first tool, the second, the third, and the fourth. So this is how the software knows where those tools are installed in the machine. And basically what I did is I went by size. So I put an 1/8 inch down shearing tool number 1, a 1/2 down shearing tool number 2, the pocketing tool on number 3, and the normal 3/8 compression bit that we cut things out with in 4. So that's what makes the connection between the actual where the tools are in the software and where they're at on the machine. Now let's go back and let's look at something. If we go to this tool group and I say, okay, I go to 3D, it actually shows a panel with those tools. And you can see where the tools are, how that fits in there. That's really, really nice. All right. Now, we're not going to use an edge group set here because normally the shaker stuff's really, really plain. And then if I wanted to change a particular feed rate or something, I would do it in the tool properties. Now we're actually ready to apply these. Once we have our nest set up, all we have to do is hit Generate G-Code. It brings this up. We make sure that we've got the correct tool set selected. We hit Calculate. Now here's what's going to happen. Here's the first tool. There's the pocket tool. So the first thing that's going to happen is these large areas are going to get pocketed out. Then we start to clean it up. There's the small bit. And finally, there's the outside. So that's exactly what's going to happen on the machine. That's what I want. I'm going to hit G-Code. It actually generates the G-Code files, and I send those out to the machine control, and let's go make these doors. Our MDF Shaker Doors came out really, really good, and the ball screw technology really shines here because you can see how perfect those blends are. And you know, thanks to the dust dock, it's not going to take very much to clean this up. I hope you enjoyed the video. If you need more information, you can contact us at ShopSabre.com. Thank you for watching.